Hello everybody, my name is Phil Lewis and I'm the CTO of a company called Pureinsights. We specialize in search systems. I'm a search industry veteran. I've been working in the search industry now for just over 30 years and performed literally thousands of projects in that time for our clients and customers worldwide. I've never been more excited about search than I am now in that entire time, and there's a couple of reasons why that's the case. The main one, of course, being what Google is doing for the internet and search in and around NLP and knowledge graphs and deep understanding of the queries themselves, but also because we now understand how Google does what it does, and we are starting to apply those same techniques and capabilities to behind the firewall applications, as well as custom specific site search applications over customer data rather than just generic internet data. And this is a really exciting time for the search industry because we can now deliver on the promise of search, not only by finding a list of documents that match the search criteria, but also answering questions directly by deeply understanding the question using NLP capabilities, looking up the information in a knowledge graph and or search engine working hand in hand together, and then presenting that answer back to the user as a discrete piece of information that they can use and action in their everyday lives. In recent years, Google has moved the needle forward in terms of search very significantly by inventing a wide variety of different types of technologies. And probably the first and foremost of these technologies that enables us to ask questions of Google rather than just keyword types of searches that we've been used to in the past is this incorporation of a knowledge graph into the Google mix. It hasn't replaced the search engine. It works hand in hand and sits side by side with the search engine. And it enables Google to do things that they've not been able to do, the general industry of search has not been able to do up until the last few years or so. Along with that, though, they've also innovated in and around natural language processing, NLP capabilities. They've invented some new, very exciting technology called word embeddings, which they incorporated into their relevance ranking algorithms and query understanding algorithms in recent years. And they're also advancing from word embeddings into sentence embeddings. And from these technologies has spawned a number of features that we use day to day in Google today that we've not been used to in the past. And some of these features are still not in traditional search engines, the non-Google search engines, the Elasticsearches, the Apache Solars, the Covios. One more technology worthy of note before we get into the demo is this technology loosely bound as word embeddings. Google has named it Burt, at least that's one of their variations of a theme. Many more are coming down the line, of course. But what Burt does is it uses a machine learning algorithm to read language and start to understand the nuances of all words. So every English term that has been seen by the machine learning system has then been placed, as you can see on the screen here, into an n-dimensional space. What you're actually looking at here is a 3D representation of that n-dimensional space. Think of it like a shadow of an n-dimensional space. And typically the number of dimensions that's captured in and around these word embeddings is 200 or more dimensions. So you can see it's quite a sophisticated kind of vectorization of terms. And this feature alone has significantly driven forward natural language processing capability, deep understanding of queries, deep understanding of text as we're indexing documents, and really enables us to do now what we've never been able to do in the past with traditional keyword-based search engines. So the context of this search interface is mainly around a public kind of website who processes and understands a whole bunch of information in and around projects. And projects are tied to locations, and projects also have publications which are published to those projects. In addition to that, there's some information in this particular website talking about electronic tenders, which are publicly presented and made searchable, so for full kind of discoverability reasons. So we'll do a couple of queries on this and just see what we get. So thinking about the project use case, maybe I'm just interested in anything to do with this particular project applicate. So at this point, the user intent has been understood that it looks like you're interested in projects, primarily because of that keyword, and the project that you're interested in is that. So this is fairly simple in its kind of view. But it might be that I was interested in the locations in and around project applicate. You can see here, these are all the locations, and every one of these locations is tied to project applicate, as we can see on that list there. So the system kind of has hedged bets a little bit here and said, looks like you're after projects, but maybe you're interested in these locations as well. As the query becomes more descriptive, then the system can get a much better grasp of what you're actually asking for. So if I said something like all locations on Raptor, so this time it understands that I am kind of talking about Project Raptor, but it's locations that I'm interested in more than anything else. And that's why locations are coming up first. But again, all of these locations are with regard to Project Raptor. Maybe my context is again subtly changed. All project locations near Cologne. This time we're not limited to a specific project. These are all the project locations inside of Cologne, regardless of the project actual name itself. So here we can see we've got a good interaction, a good kind of set of results that are being returned to the user. So this is a combination of the NLP system, the knowledge graph, helping the system understand the query and the intent of the query much better, and then of course the algorithms that go out and bring these set of results back. If I completely switch tack, this time I'm not interested in the projects or the locations, but maybe the publications. So again here I can do a quick search, peer articles by H. Calcutt. You can see that it's found these objects called peer-reviewed articles, and H. Calcutt seems to be prevalent within that. So this again is an example of query snapping, and I can just prove that. If I go into publications, you can see that the system has already selected H. Calcutt from the authors, and it's already selected peer review articles from the published as, or the type of object, essentially, and that's why we've got this pretty accurate result set being returned. Again, NLP just understanding what the user is asking for and snapping directly to that. Just one more example of that, kind of on steroids. If I do this kind of query, Pegasus projects funded by the RIA that are signed, you can see that it's identified 3 things from the knowledge graph which are of interest. If I then click on the projects tab, again, we can see the query snapping has taken place here. So funded by the RIA has effectively been turned into funding scheme RIA in the facets. Pegasus projects, so projects has been selected from that, and Pegasus is the project acronym. And then we that are signed, and the system has found a facet value in project status of signed. And again, that's one of the contributing reasons as to why this particular NLP query has found these 2 objects very, very accurately. Okay, a couple more queries just to show the power of the knowledge graph combined with search. Maybe I want to ask it a question like this, essentially, who are the authors of publication, blah, blah, blah. And of course, this key ID here has been mapped into this entity by the system, and it realizes then that I'm not after just that object or that entity. I'm after a specific attribute of that entity, which is called authors because of this, and then it just reads those out. So this is very similar to an experience you would get from a knowledge card that Google would provide at the top of a result set once it deeply understands the query and just goes away, finds that information and brings that straight back. And This is kind of a keyword version of that query, but it still works. But if I go in and actually ask a specific question, what is the award value of the Tyler Brothers escalator part contract? So the system has taken that. It's understood that we're interested in an object or an entity within the knowledge graph that is talking about the Tyler Brothers escalator parts contract, which is this. This is a contract in its own right. So that's why this particular entity has been found. And then it's clear that we're actually after the award value of that, so it just reads that award value out directly from the knowledge graph. Of course, if I wanted to see the object, so if that wasn't the right answer or wasn't an answer I was expecting, or maybe there was no answer at all, then I could go straight in and look at the award notice of that contract and see exactly the detail that I'm after directly from that. So here we are switching context a little bit into the domain of a learning management system or a knowledge management system, and I may wish to ask it a few questions. Just like the last example, maybe that I'm after a piece of information that's held in the knowledge graph. So in this case, what are the chapters of the Advanced Apache Spark course? Let's execute that query, and just as we had in the last example, this information in this information card here is coming directly from the knowledge graph. So it's identified this is the entity that we're interested in. This is a course, and the element or the attribute that we're interested in finding out about is the chapter. Okay, and of course there's the Apache Spark course, the advanced one, not the beginners, not the intermediate. It's the chapters that we're interested to get there. So again, in case this answer doesn't surface for whatever reason, because maybe the information isn't in the knowledge graph, then of course it always takes us and falls back to the traditional search, and here it's actually still found the real object itself, but it's snapped to it from these elements here, Apache Spark and Advanced, or part of the clues that we gave it as part of the query itself. And one last example of a query that does not find the information in the knowledge graph directly, but it does find it through the featured snippets capability. Something like this. So what is an CISM? When we ask that query, data is not in the knowledge graph, but it has successfully found a good piece of content that does describe exactly what that is. We can see this is not just any normal kind of hit highlighting, because normally in hit highlighting, the terms you entered into the query are the things that it highlights, and this isn't highlighting that. It's actually highlighting this term here, which the NLP system is fairly confident that it explains exactly what a CISM is. And that's the reason why this part of this document has been highlighted in this way. That's just the featured snippets capability. If you would like to find out more information on how we implement Google-like search experiences on corporate data, together with knowledge graph-based answers, featured snippets, and industry-leading relevance ranking, please email us on info@pureinsights.com. Thanks for watching.